The distributive property. Definitions. A term is a number, variable, or product of a number and one or more variables. A constant is a term that has no variable. A coefficient is a numerical factor of a term. And like terms have exactly the same variable and factors. For example, 3x and 4x are like terms because they share the same variable x. 2xy and negative 5xy are like terms because they share the variable factors xy. This expression, 6a squared plus 5ab minus 3b minus 12, has a total of 4 terms because there are four terms that are separated by our operation symbols. The 6, the 5, and the 3 are all coefficients because they are numerical factors of these terms. The 12 is a constant because it does not have a variable. The distributive property states that for every real number, a, b, and c, a times the quantity b plus c equals a times b plus a times c. So the distributive property is technically just multiplication, but you're multiplying this numerical factor by everything inside the parentheses. So a times b plus a times c. This also works for subtraction. It's the same thing. You multiply a times b and you get ab minus a times c. So you're multiplying the numerical factor by everything inside the parentheses. You can also write these two mean the same as the two examples we just went. It just has the quantity in front, but you do the exact same thing. So this would be b times a plus c times a. Or b times a minus, so we have the minus here, c times a. So your numerical factor can be in the front or in the back, and the distributive property will still work. So let's look at some examples. We have 5 times the quantity, 20 plus 6. So you are going to multiply the 5 times 20, which we have here, plus the 5 times 6. We can also have the numerical factor in the back of the quantity. You're still going to get the same thing. 20 times 5 plus 6 times 5, which we get right here. Let's look at the next one. 9 times the quantity of 30 minus 2. We have 9 times 2 because you distribute this factor to everything inside the parentheses. So we get 9 times 30. 9 times 2. So we have 9 times 30 minus 9 times 2. This also works if the numerical factor's in the back. We have 30 times 9 minus 2 times 9. We can also use the distributive property to help us with mental math, to break something down to make our multiplication easier. So for example, if you had 34 times 102, well, we can use the distributive property to break this down to 34 times 100 plus 2, because 100 plus 2 is the same thing as 102. They're equal to one another. So now, using the distributive property, we can distribute this 34 to everything inside the parentheses, and we get 34 times 100 plus 34 times 2. Well, this is easier mental math for me because I can multiply 34 times 100 easily in my head. We get 3,400 or 3,400, and 34 times 2 is 68. When we add these together, we get 3,468. Well, if you were to actually multiply 34 times 102, you would get the same answer as if we did it through using the distributive property. So let's look at simplifying some expressions. So what our goal is to distribute the 2, or our numerical factor for number 1, to everything inside that parentheses. So we're going to multiply. So we have 2 times the quantity, 5x plus 3. So we're going to multiply this 2 to every term inside that parentheses. So 2 times 5x is 10x. This cannot be reduced anymore or simplified, so we leave it. And then 2 times 3 is 6. So 10x plus 6 is our simplified version. Let's look at number 2. We have 1/3 times the quantity 3b minus 2. Well, 3b times 1/3, so we have 3, which can be written as 3 over 1, times 1/3. Well, that gives us 3 over 3, which is 1. So this is 1b. Do the same thing with the 2. Well, 1/3 times 2 over 1. 2 times 1 is 2. 3 times 1 is 3. So our answer is B minus 2/3. Let's look at number 3. You have 6 times the quantity m plus 5. So we want to distribute the 6 to everything inside our parentheses. 6 times m gives us 6m. 6 times 5 gives us 30. We cannot simplify these because they're not like terms. So 6m plus 30 is the simplified expression. Let's look at number 4, excuse me. We have 2 times the quantity, 3 minus 7t. So we want to multiply this 2 by 3. Well, 2 times 3 gives us 6. Now we're going to minus 2 times 7t. Well, 2 times 7 is 14 times t. This cannot be simplified anymore, so that's our simplified expression. Now, if you look here, we have a minus sign on the outside. This is actually considered a -1. This is the multiplication property of -1. Mathematicians are lazy. We don't like to write the 1 if we don't have to. So anytime you see a minus sign on the outside of our parentheses, it actually represents a -1. So we are going to distribute this -1 to everything inside our parentheses. So we have -1 times 2x plus a -1 times 1. So all I did was distribute to each one in the parentheses. -1 times 2x is a -2x. -1 times 1 is plus a -1. So we can rewrite this based on our definition of substitution as -2x minus 1. And our third one, this is also the multiplication property of -1. We have 3 times -1. And then we have minus 8a times a -1. So now we have 3 times a -1 is a -3 minus 8a times a -1, which is a -8a. Well, this does not look simplified because we have these two minuses up against each other. Well, we know subtraction is adding the inverse. So we are going to add the inverse. So our answer in simplified version is -3 plus 8a. Combining like terms. When you are combining like terms, they must have the same variable, and that's our VIC number 1. So what that means is if you have 5y squared and 10y squared, these are like terms because they have the same variable factors, y squared. 3x squared and 2x are not like terms because this is an x squared variable factor and this is only an x. They are not the same. So let's look at some examples. You have 3x squared plus 5x squared. Because these are like terms, because they share this x squared, we can use the distributive property to simplify. We have 3 plus 5 times x squared because they both share that x squared. Well, 3 plus 5 is 8, so it's 8x squared. Negative 5c plus c. Well, remember the multiplication property or the identity property means that this is a 1c because 1 times any number is itself. So now they have in common c, so these are like terms. We're going to use the distributive property to be able to simplify. We have in parentheses the negative 5 plus 1 all times c. And this works because if I actually distribute, I will still get negative 5c plus 1c. So negative 5 plus 1 is a negative 4, so our answer is a negative 4c. Number 3, 7y plus 6y. Well, they have the same variable, y, so we can combine 7 plus 6, the quantity, times y. Remember, this works because when you distribute, you get 7 times y plus 6 times y. Add 7 and 6 together, our answer is 13y. Number 4, you have negative 9w to the third minus 3w to the third. Well, they are like terms because they both have a w to the third power, or w cubed. So we're going to rewrite this using the distributive property of negative 9 minus 3 times w to the third. Negative 9 minus 3, we add the inverse, so we get a negative 12 w to the third. We also can write expressions using the distributive property. So number 1 says write an expression for 3 times the quantity. Quantity is very important, and we know that that means it's going to be parentheses. Anytime we talk about the quantity of something, it's represented by parentheses. So it's 3 times the quantity of x minus 5. So we know x minus 5 is going to be inside that parentheses, and our numerical factor is going to be 3 on the outside because it's 3 times, so 3 times the quantity of x minus 5. Number 2, you have negative 2 times the quantity of t plus 7. That quantity, remember, means the parentheses. So t plus 7 is in parentheses, and that negative 2 is being multiplied by everything in that parentheses. Let's try number 3. The product, so product, which means multiplication, of 14 and the quantity of 8 plus w. Quantity, we take parentheses, so inside that parentheses is 8 plus w, and we're multiplying 14 by the whole quantity. So 14 times the quantity of 8 plus w.